Okay, today we're going to talk about some more properties of chords. Remember that a chord is a segment who has endpoints on a circle. So in this picture down here, AB is a chord and BC is a chord. Here's a theorem for you. In the same circle or in two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you see this picture right here in this example, AB has 9 units and BC has 9 units. So those segments are congruent. Those chords are congruent. So that means that their arcs are also congruent. So if we know the measure, number one says the measure of AB is 110 degrees. So this arc is 110 degrees. Then BC would also be 110 degrees because their chords are congruent. So if the chords are congruent, then the arcs are congruent and vice versa. So the measure of BC is arc BC is also 110 degrees. Okay, let me erase my markings because the next problem is going to need some different information. It says if the measure of arc AC, so from here to here, because that's a minor arc, is 150 degrees, find the measure of arc AB. So, okay, so let's first find the measure of the major arc. So 150 is a minor arc. So the major arc from A to B to C is going to be 360 minus 150. So 360 minus 150 is 210 degrees. So that would go from A to B to C. Well, I also know that AB is going to be congruent to arc BC. So if I take 210 and divide it by 2, then that would tell me that the measures of arc AB and arc BC are each going to be 105 degrees. So the measure of AB is going to be 105 degrees. And you can check it. 105 plus 105 plus 150 should equal 360 degrees altogether. So we found the measure of the major arc and divide it by 2 because we know those two arcs, AB and BC, have to be congruent to each other. So that's why I could divide them by 2. All right, here's some more theorems. If one chord is a perpendicular bisector, now let's talk about perpendicular means it makes a right angle. Bisector means it cuts it exactly in a half. So this segment SQ is the perpendicular bisector of segment RT there. So if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So this chord SQ right here must be a diameter, which means it's going through the center of the circle. It means it's also 180 degrees. Lots of things right there. And this is basically, it's almost a converse theorem here on the next one. It says if a diameter of a circle is perpendicular to a chord, then the diameter bisects that chord and it bisects the arc. So that means these two arc measures right here will be the same. So basically, if it's a diameter that's going to bisect the chord that's perpendicular to it, and it's going to bisect the arc, which means congruent measures, equal measures. So it says find the length of AC. Well, AC right here is, get my highlighter, is a chord. All right. But it's a perpendicular bisector, or it's being bisected. It's perpendicular to segment BD, which is going through the center, which is a diameter. So that means it's being bisected by it. So if this segment over here is 7 units, and this segment right here is 7 units, and the whole entire chord is going to be 7 plus 7, which is 14 units across. So the length of segment AC would be 14 units because the 7 is going to be duplicated on the other little segment. All right. Find the measure of the arcs. All right, so this time, instead of focusing on the segment, it's going to focus on the arcs. And BD right here is a diameter that goes through center A. So that's a diameter. That means that these two segments are congruent, and it also means these arcs are congruent. So if two things are congruent, I can set them equal to each other. So before I can find the measure of the arcs, I need to find what x is. So I know that CD is going to be congruent to DE. So I can set 9x equal to 80 minus x. Solve it for x. You add x to both sides. 10x equals 80. Divide by 10, and x equals 8. Boom. So x equals 8. 9 times 8 is going to make this 72 degrees. And this other one should be 72 degrees, but I'm going to check it. 80 minus 8, yep, that's 72 degrees. All right, so the measure of arc CD is 72 degrees. I just found that by plugging it in my 8. Same thing, DE is 72 degrees. Whoops, sorry. So to find CE, and again, it's talking about the minor arc, so it's not the long way around, it's the shortest way around. So CE is from here to here. I can add 72 plus 72, or I could double it, multiply it times 2, and that's going to be 144 degrees. I don't know why things are disappearing from my screen, but y'all can go back and rewind it, I guess. So that is 144. Okay, so here's the complicated part. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if AB is congruent to EF, then that means the distance those two points are perpendicular to the center are going to be congruent as well. So that's kind of confusing until we see it in a problem. So let's just go ahead and look at this problem right here. And yeah, it's kind of blown up, kind of crazy. See if I can shrink it a little bit. It says QR and ST are equal measures and they both equal 16. That's what that means right there. Find the length of CU, which is this length right here. Okay, and it just says that's 2x. So that means I'm going to have to find what x is. Well, since both of those chords right there are 16, QR and ST are both 16, that means that they're equidistant to the center. So that means that CU is going to be the same length as CV. So that means I can set 2x equal to 5x minus 9. Well, I'm going to get my x's together, subtract 5x. Things are just deleting like crazy today. So negative 3x equals negative 9. Divide by negative 3. X equals 3. Okay. But it said to find the length of CU. Well, CU is going to be 2 times 3, which is 6. So CU is 6. CV is also 6, right? And I can check it. 5 times 3 is 15 minus 9. Yep, that's 6. Okay. Now, here's the complicated part. Then, find the radius of circle C. Let me change colors here. And I might need to blow my picture back up so we can see. So a radius of circle C is going to be a length from, I'm just going to do it over here because it's easier to see. It's going to be a length from center C to an outside edge. So CR right here could be a radius. Well, that looks like a hypotenuse of a right triangle because it's perpendicular up here at the 16. Well, to be perpendicular to a chord, it's going to bisect it because it's going through the center. So that means that length is 8. So 6 is a leg, 8 is a leg, and R is the hypotenuse. So you're going to plug it into the Pythagorean theorem to get R. So r is the hypotenuse, so we'll say 6 squared plus 8 squared equals r squared. 6 squared is 36, plus 8 squared is 64, equals r squared. Oh, nice. 36 plus 64 is 100. And you take the square root, and that would give you 10 equals r. So the radius of that circle would be 10 units. Now, unfortunately for me and you don't have a practice for this lesson. So hope you enjoy the video and enjoy not having a practice for this one. And you'll get a practice for the next one, I promise. I miss you guys. Have a good day.